Welcome to biology. In this video, we are continuing our biochemistry unit, and we are focusing in on solutions and mixtures. So to start with this, the definition of a solution is a uniform mixture of two or more substances, and a solution is typically some kind of liquid. It's made up of two parts. We have the solute, which is the substance being dissolved, and the solvent, the substance doing the dissolving. Now, water's chemistry allows for some really easy formation of solutions. In fact, water is considered the universal solvent. And all living things really depend on water for survival because water is able to allow things to be dissolved inside of it. So I'll show you here what that really looks like. So water is considered that universal solvent because it's really good at dissolving polar solutes. In this example here, in the beakers on the right, you see a big blob in the middle, and that is a single, like a zoomed in version of a single molecule of sodium chloride or table salt. Now, the little dots around that, those are individual molecules of water. Sodium chloride, that's formed using an ionic bond. And when sodium chloride is in water, that ionic bond is kind of split apart into the individual components of sodium and chloride. And that's this color picture here on the bottom of the screen. So what happens is the electron that was being stolen away from the sodium stays with the chlorine. So the chlorine still has this slight negative charge, the sodium has a slight positive charge, and because water is polar, the slightly negative side of the water is attracted towards the sodium, and the slightly positive side of the water is attracted towards the chlorine. And in this way, water is able to dissolve that sodium chloride, and it's able to separate out. Now, if you remove the water, so you evaporate the water out, that sodium and chlorine is going to come back together to make salt again. You're not going to suddenly have that metal and poisonous gas. So in this example, the solvent, so the liquid doing the dissolving, would be water. And the solute, the thing being dissolved, is the sodium chloride. Now it's time for you to try. Looking at this example of hot cocoa with warm milk and cocoa powder, which one of these pieces is the solvent, the solute, and the solution? Go ahead, pause the video real quick, see if you can identify each of the pieces. You should have been able to identify that the warm milk is the solvent, the cocoa powder is the solute, and when the two are combined, you make a nice even mixture, which is our solution of hot cocoa. There are two main categories of solutions. There's the hydrophilic or water-loving solutions. These are substances that can dissolve in water. So anything that is somewhat polar can dissolve in water. So things like salt and sugar. The other type of solution is a hydrophobic or water-hating. This means that that substance is not able to dissolve in water. So a way to remember this, like dissolves like. So water is polar. So anything that is polar loves water and is able to be dissolved in it. So to break down these terms, the prefix hydro is talking about water. Philic means loving, so hydrophilic, water loving. The other term, hydrophobic, again, water is hydro, but phobic. Think of having a phobia of something. Many people have a phobia of spiders or a phobia of being in tall buildings. So phobia means you don't like something or you hate something. So hydrophobic means water hating. So that substance does not want to be dissolved in water. and it ends up kind of either floating or sinking and not mixing in. This can lead to different types of mixtures. So all of these solutions are technically special types of mixtures. So again, a mixture is a material composed of two or more elements or compounds that are physically mixed together, but there's no chemical reaction taking place, so you're not chemically combining the two. Again, there are two different types of mixtures. The first type is called a homogeneous mixture, and the prefix homo means same. So a homogeneous mixture means that everything is mixed really evenly, and if you take a little sample from any point within the mixture, each of those samples is going to be exactly the same. So if you think of having a glass of lemonade, so no pulp in this lemonade, it's just pure juice in there. Well, that lemonade, your first sip should taste the same as the last sip. So that's a homogeneous mixture. It's nice and evenly mixed. The other type is heterogeneous, and these are components that separate out in the solution. When we are thinking of mixing a hydrophobic substance into water, that creates a heterogeneous mixture. Think of Italian dressing for on your salad. You have that oil and there's some seasonings that are chunks in there, and you have a liquid again on the bottom. And before you pour out Italian dressing on your salad, you give it a good shake so that way everything gets mixed up again and it's not this just pouring out an oil first and the next person that pours it out doesn't get any of the oil, they get some of the other stuff in there. So a heterogeneous mixture means you have a bunch of different components. So the prefix hetero means different. So homo means same, hetero means different. So in a heterogeneous mixture, if you take a sample from a bunch of different points, they're not all going to be the same. So let's practice this really quick here. So take a moment, see if you can identify if each of these are homogeneous or heterogeneous. So go ahead, pause the video, see if you can figure it out. Well, we already talked about Italian dressing being a heterogeneous mixture because you have to shake it up in order to mix everything again. It all just wants to separate out. You have that suspension where the oil is separated out from the rest of the liquid. That's because it's hydrophobic. It doesn't want to mix in with the water. Then tap water, that would be a homogeneous solution. Hopefully your tap water does not have any chunks in there, and your first sip of tap water is exactly the same as the last sip of tap water. What about Coca-Cola? Well, that should be a homogeneous solution as well. Every little bit of that beverage should taste exactly the same. If it didn't, we'd have some serious questions for the Coca-Cola company. And then finally, trail mix. That would be a heterogeneous mixture because you have individual chunks in there. Now, if you took trail mix and put it in a blender and it was all blended super duper fine, then maybe it might be a little bit more of a homogeneous. But since there are visual chunks in there and you can separate out each of the pieces, that makes it heterogeneous. In summary, solutions, they're made up of two parts. You have the solute and the solvent, and water is the universal solvent. Solutions are just fancy mixtures. Usually solutions are some kind of solid or powder dissolved in a liquid. So the powderish or solid would be your solute. Your liquid is your solvent. Mixtures are physical combinations of two or more substances. Difference between a mixture and some chemical compound is because there is not a chemical reaction happening. You're just physically adding them together. That means that there's a way that you can physically separate them back out. And then make sure you know the difference between the terms hydrophilic and hydrophobic. So hydrophilic, water-loving, hydrophobic, water-hating. And also know the difference between homogeneous and heterogeneous. So homogeneous means it's same throughout the entire mixture or substance. Heterogeneous means that you can separate out the individual parts. It's not an even mixture of all of the pieces. Again, I know I went quickly. Please send me your questions and comments, thoughts on this video, and I'll get back to you as soon as I can. And make sure that you rewatch anything that was confusing. And I hope that as you watch this video, you were able to learn something.